All right, so today we're talking about law of sines. So we have our big old law of sines sheet, and we're going to start by understanding where it comes from. Okay, so the law of sines is used to solve oblique triangles. So anybody know what the word oblique means? Yes, sir.
No.
Okay, thought you might know. Yes, we don't have any 90-degree angles in this triangle. Okay, all of our angles are something other than 90 degrees. So there's no right angle, no right triangle. Okay, non-right is what we're talking about here. So far, so good? Okay, so you learned the law of sines, but you probably don't know where it came from.
Is there a difference between an oblique triangle and a scalene triangle? Because that's what we call them in algebra.
So we call them scalene, obtuse, and right.
Okay.
And equilateral, equiangular, we had all kinds of words for them, right? And so, yep, so when we had obtuse and acute, that kind of encompasses oblique. The key is that it's not a right triangle. Anything other than a right triangle, okay? All right, so for right triangles, we have good old sine, cosine, tangent, Pythagorean theorem, lots of tools at our disposal, right? However, for non-right triangles, we have to use something called the law of sines and also something called the law of cosines, okay? So we're going to start out with this triangle, triangle ABC, and triangle ABC is an oblique triangle. I'm going to put a little D here, and we're going to first of all start by talking about what the sine of angle A is in this triangle ACD. So what is the sine of angle A? H over B. Sine stands for the opposite over the hypotenuse. So H over B would be the sine of angle A in that left triangle. Right triangle, what is the sine of angle B? H over A. All right. Do we all agree that H is equal to H? It's the same height in both triangles, right? All right, so let's solve each of these for H. H would be equal to what? Sine of A times B. So let's put the B out in front so we don't confuse ourselves, but sine of A times B. Okay? And on the second triangle, H is going to be equal to A sine B. Now, why the difference in lowercase, uppercase? Remember back in geometry, we said that we're going to label all points with a capital letter, right? And then we use a lowercase letter to signify sides. All right, so far so good? So, same H in both. Let's set these equal. B times the sine of angle A is equal to A times the sine of angle B. So far so good? Now, to get it into a law of sines form that you're comfortable and familiar with and that you used last year, we're going to divide both of them by the side lengths. So if I divide this side by side A, I get A over A, which is 1. Divide this side by A as well, because whatever I do to the right side of the equation, I must do to the left. And if I divide this one by B, B divided by B is 1. If I divide the left side of the equation by B, I have to divide the right side of the equation by B. And lo and behold, we have sine of angle A over side A is equal to the sine of angle B over side B, which is part of our law of sines, 2/3 of it. So far, so good? Had we used a different height, right, a different perpendicular to the base, a different altitude, we could have gotten the sine of C over C with the sine of B over B, and so forth. Make sense? Okay, so here's your law of sines. Now, some textbooks, some teachers prefer to call it side A over the sine of angle A equals side B over the sine of angle B equals C over the sine of C. I don't care which way you write it. You decide which one works best in your brain. Make sense? Okay. Now, let's actually solve a triangle using the law of sines. Okay? So, we're going to solve triangle ABC. If angle A is 32 degrees, angle B is 50 degrees, and side C is 18.7. So let's write it out. The sine of 32 over a, little a, has to be equal to the sine of 50 over little b, which has to be equal to the sine of angle C over 18.7. But the problem is we won't have a complete fraction here to be able to solve a proportion, right? So is this one solvable using the law of sines? Good. It is, because we can figure out what angle C is, right? Let's add angle A and angle B together, and we get a total of 82 degrees. And all three angles of a triangle have to add up to 180. So if we do 180 minus 82, we know that angle C is 98 degrees. So sine of 98 over 18.7. All right, so far so good. We're not stymied yet. So now we know that we have angle C. We need to find side B, and we need to find side A, and then we'll have our three parts to our triangle that we didn't know before. Okay, so everybody cool with using the right side here, the right two fractions, because we've got it somewhat complete? So let's go with cross multiplying here. The sine of 50 times 18.7 has to be equal to b times the sine of 98. Then to get the b by itself, we're going to divide by the sine of 98, right? So b will be whatever we get when we take 8.7 times the sine of 50 and then divide by sine of 98. All right, so we'll pull that calculator out. What mode do we have to be in? Degrees, so check to make sure that you're in degree mode. We're good. And we're going to take 18.7 and we're going to multiply that by the sine of 50, close our parentheses, and divide by the sine of 98. And we get 14.5. One decimal point, probably good enough. All right, so we're at 14.5 for B. And I always appreciate it if students make a box around any things that they're finding, because it helps me to be able to find it as well. All right, one more thing to find. Letter A. Can we use Pythagorean theorem here? No, not an oblique triangle, right? Or not a right triangle, it's an oblique triangle. So we have to solve for A using law of sines again. All right, so we know the sine of 32 divided by A is equal to, let's keep going with the part that we knew before, sine of 98 over 18.7. So A times the sine of 98 will be equal to 18.7 times the sine of 32. To get the A by itself, we're dividing by the sine of 98. And back to the calculator we go. $18.7 times the sine of 32, close parentheses, divided by the sine of 98. And we get 10.00, or 10.01. Everybody cool with 10.0? All right. So A is 10. And we've done a law of sines. So far, so good? Okay. Is it familiar to you? You remember it from last year? Law of sines we used before. All right. So next, we want to talk about the area of a triangle. And then we'll talk about something called the ambiguous case. All right, so let's find out where the area of a triangle's formulas come from as well. If you need the area of an oblique triangle, okay, I want to know the area of this triangle ABC. Anytime I'm finding the area of a triangle, we take base times height divided by 2, or half the base times the height. So far, so good? Okay. So, what would be the area of this particular triangle? 1/2 of C times H. Base times height. Okay? But a moment ago, we talked about the height being something in terms of sine, didn't we? So what is the sine of angle A? H over B, opposite over hypotenuse. And so H has to be the same thing as B times the sine of A if we get the H by itself and multiply both sides by B. So the area is 1/2 the base times B sine of A. Or, more commonly written alphabetically, 1/2 BC sine A. Area of a triangle. 1/2 BC sine A. Notice BC are two sides. Sine A is not the opposite side, right, of B or C. And so we have 3 equations that we can use depending on which angle we're given and which sides we're given. We can use 1/2 BC sine A, which is what we just found. We can use 1/2 AB sine C, or we can use 1/2 AC sine B. Letter, other angle. So far, so good? Okay, so let's find the area of this triangle. If angle C is 102 degrees, side B is 52 meters, and side A is 90 meters. Does everybody agree that we have 1/2 AB sine C here? All right, so 1/2 times 90 times 52 times the sine of 102. All right, good old handy dandy calculator. 1/2 times 90 is 45. So we're taking 45 times 52 times the sine of 102. And we get 2,288.9 square meters. Questions on that one? Easy formula to learn, easy formula to forget, okay? But hopefully you see where it comes from and you can derive it if you have to. When that amygdala gets in charge and you've forgotten something and you need to get your prefrontal cortex engaged. Make sense? Okay. Now, on to the ambiguous case. Okay? So first of all, sometimes, even as math teachers, we have to be careful. Because when we make triangles or we use side lengths, if we don't think about what we're doing, we can create a situation where no triangle exists. Okay? 52-degree angle. That's angle A. Side B is 10. How long must A be in order to make a right triangle? Would you agree that A is not long enough right now? We can pivot it up here on this point, and no matter what we do, we're never going to reach the opposite side. Okay? So let's figure out what the height of this triangle would have to be. How long would A have to be in order to make it a right triangle? Well, how would we figure that out? I want to know the opposite. I have the hypotenuse. Opposite hypotenuse means? So far so good? Okay, so if I take 10 times the sine of 52, I can find out what h would have to be in order to make that a right triangle. What do we get? .88, so 7.9. All right, if h is 7.9, we're going to get a right triangle. That's the smallest h can be to be able to make a triangle. Does that make sense? So that's the smallest a can be in order to make a triangle with a 52-degree angle and a side that's next to it that's 10. So far so good? Now, watch what happens when we make that 7.9. All right, so here's our 6.5. It was not long enough. I can pivot it, and no matter how I swing it, like a pendulum, it's not going to reach that triangle or that base. Now if I make it 7.8, still not long enough, is it? Almost there, but can't reach it. When I make it 7.9, I can be sensitive enough to just get it to the right spot. There we go. Watch what happens. We get a triangle. So far so good? Okay. Now, what would happen if we made this guy, I don't know, 8.2 to match our activity that we're doing? Right now it's too long, isn't it? Goes beyond it. But let's pivot it over here. You see that we get a triangle? Okay? That's because I know an angle, a side, and a side. Remember back in geometry when we taught you 5 ways to prove triangles congruent? Anybody remember what any of them are? Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And one with H. Hypotenuse, leg, HL. Those were the 5 ways we could do it, right? We never had one that was ASS or SSA. And it wasn't because we were worried about you saying a bad word. It was because it does not make unique triangles. So everybody agree we got a triangle here that has an angle of 52 degrees and a side that's 10 and a side that's 8.2? Watch what happens when I pivot my hinge. If I put my marker down first. There's another triangle. Are those 2 triangles equivalent to each other, congruent? Absolutely not. And so that's why we have an ambiguous case. We can have times when we get 2 triangles with an angle and 2 side lengths. Make sense? Last year we didn't worry about it too much. We said that's coming up for next year. This year we're going to find both of those triangles. Does that make sense to everyone? Okay, so let's actually use our protractors to figure out how this works. Okay, I'm going to have you go to your protractor, pull it out. Those of you who have the fancy protractors, you're going to put the little pivot point or the little hole, the circle, on. You're going to close it up kind of, and you're going to put the hole where it pivots onto the angle A, and you're going to open it up so that you see a 30-degree angle, or 29, close enough. 29, 30, we're not going to be that precise. Those of you who have a regular protractor, you're going to put that base horizontal to it, and we're going to mark off a 29-degree angle. So we want to have it laying here with a dot on the vertex on that little hole, that little plus sign, and we're going to go find 29 degrees, and we're going to put a mark there. And then we're going to extend that out with our ruler. So everyone should have something that looks like it's about a 30-degree angle, close enough for what we're doing. And I gotta erase. I went a little crazy. All right, so label that 29 degrees for me. There's our angle A. Now we need to do a side B that is 10 centimeters. Okay, so this is going to be your side B, and you want to mark it out 10 centimeters. I'm going to go 10 inches since I have an inch ruler. That's pretty darn close. There's my 10 centimeter, 10 inch mark. So that's side B. And then I need to have a side A that is 6. So opposite angle A, I'm going to have a side A over here that is 6 centimeters. So when I mark it off as 6 centimeters, I'm going to have something that looks like this. So far, so good? So those of you who with that protractor, you have to put a kind of a dot in it using one of those little dots. That's going to help you get your angle. Everybody got a triangle that looks somewhat similar? Okay. So here's angle A. This is side A. If this is side B, angle B is down here, and that leaves C to be up here, and this is side C. So we know 3 parts, we've got to find 3 others. Okay, so we're going to use our law of sines. Sine of 29 over 6 equals sine of angle B over 10. So far, so good? We're trying to get the sine of angle B by itself. If we multiply both sides by 10 or cross multiply, now the sine of B will be 10 times the sine of 29 divided by 6. 10 sine of 29 divided by 6, right? And then we're going to get an answer that is the sine of angle B. But how do we get angle B by itself if we're taking the sine of it? Yeah, the inverse sine. Inverse sine is the inverse of sine, so we'll eventually take the inverse sine of this guy. They cancel out, we'll just get an angle B. All right, so inverse sine of 10 sine 29 divided by 6. Inverse sine 10 times the sine of 29 divided by 6, is that right? Did you get 53.9 degrees? All right, so 53.9 degrees is our angle B. We're going to put a star beside this because we're going to come back to this. So 53.9 degrees. And then we got to find C and side C. Okay, so the sine of 29 over 6 is equal to the sine of C over side C. And if we have a 29 degree angle and a 53.9 degree angle, what's angle C going to be? What is it? 97.1. So sine of 97.1. Okay, so to get C by itself, we'll be taking 6 times the sine of 97.1 is equal to sine of 29 times C. So if we divide C by the sine of 29, we should get side C. Do it to both sides, we get the side C. So 6 times sine of 97.1 divided by sine of 29, what do we get? 12.3. Okay, so here is one triangle. Angle B, 53.9. Angle C, 97.1. And side C, 12.3. Box it so I can find it. So you can find it, you know where it's at. Now, one slight problem. This opposite side, 6, is just the right length along with this 29-degree angle to make another triangle. I'm going to do this other triangle in blue. I can also angle it this way and have an A equals 6. So here's my new triangle, my blue triangle, and it's certainly not the same as the original. Everybody agree? So we have to solve both triangles. All right, so I need to find a new angle B. I need to find a new side C. And I need to find a new angle C. Angle C is probably going to come before side C. And then I'll have both triangles. That happens when we have an ambiguous case. Only happens when it's side-side angle. Well, what do you notice about this little purple triangle here? What kind of triangle is it? Almost. Isosceles. Not all 3 sides are equal, but 2 of the sides are equal. So this is an isosceles triangle, 6 and 6. If it's an isosceles triangle, it has 2 equal legs, then that means that this 53.9 is also this angle in this purple triangle. So far, so good? I have a feeling you can easily tell me then what the other angle B is going to be. How could we find this new angle B? The blue B. Subtract it from 180. So, key, once you find your first angle B, to find the other one, subtract from 180 degrees. And we know our new B. So 180 minus 53.9 is? What is it? 26.1. We have our new angle B. And now we just have to find C and side C, and we're done. We'll have both triangles. So this guy's important. Want to keep track of him. And then 180 minus it is going to get us this other angle, the 126.1. And then 126.1 plus the 29 degrees we had originally. $155.1, right? Subtract that from 180. What do we get? 24.9 seems right. I set my notes down. And I want to go back to the calculator again. So we get 24.9. Yep, good job. That's our new angle C. So that wasn't so bad. Subtract this guy from 180 to get this one, right? Add this one plus our original and subtract from 180 to get our new angle C. And now law of sines again. So sine of 29 over 6 equals sine of 24.9, our new C, over C. Cross multiply and solve. C times the sine of 29 equals 6 times the sine of 24.9 divided by sine of 29. And I believe our new C ends up being 5.2. Okay? If you do a good job with it and you use the protractors, they'll be pretty close. Okay, we're going to be off by pencil lead and things like that, but they'll be pretty close. Does that make sense to everyone? Tomorrow we'll talk about why it happens and a way to algebraically figure out if you're going to get two triangles or not. Make sense? All right, but this never happens with hypotenuse leg. It doesn't happen with side, side, side. It doesn't happen with angle, angle, side, or angle, side, angle. So anytime they give you the law of sines and they give you two angles, you don't have to worry about an ambiguous case. Make sense? All right, so your assignment today is going to be next page of your packet. And I'll let you know which one here it is that you might want to sketch. I believe it is number 13, but I'll verify. All right, so use your time wisely. If you have questions, I'm happy to help. And front page only, that's all we have to do for tomorrow. Let's see if I can stop recording now.